In October 1995, astronomy changed forever. For the first time in history, scientists confirmed the existence of a planet orbiting a star beyond our Sun. That planet was 51 Pegasi b, a world so strange it shattered everything we thought we knew about planetary systems. Its discovery did not just earn a Nobel Prize, it opened the gates to thousands of new worlds and began humanity's greatest quest to find another Earth. 51 Pegasi b is no Earth. It is a gas giant, half the mass of Jupiter, yet orbiting its star closer than Mercury orbits our Sun. It completes a full year in just 4.2 days. Imagine a sunrise and sunset, and then within a single week, the planet has circled its star once more. The temperatures are infernal, over 1,000 degrees Celsius. Clouds of metal may drift across its skies. And yet, this bizarre world proved one thing: planets can exist in places we never thought possible. Before 1995, our theories of planet formation were simple. Gas giants like Jupiter were expected to form far from their stars, where ice and gas could gather in the cold of space. But 51 Pegasi b was different. A giant world hugging its star so tightly that no model of the time could explain it. Astronomers were stunned. How could a planet this massive survive so close to its sun? Was it born there, or had it migrated inward after forming far away? The answers forced scientists to rewrite textbooks and opened the door to an entirely new class of worlds, the hot Jupiters. So how did astronomers find this hidden world in 1995? They didn't see the planet directly. Instead, they watched the star itself. As 51 Pegasi b tugged on its sun with its gravity, the star wobbled ever so slightly. That wobble shifted the star's light, stretching and compressing its spectrum in a cosmic fingerprint known as the Doppler effect. By measuring this tiny shift, just meters per second in speed, Michel and Didier Queloz proved that an unseen planet was there. It was the birth of a new technique, the radial velocity method, which has since revealed hundreds of alien worlds. The discovery of 51 Pegasi b was more than a single planet. It was proof that planets exist beyond our solar system. And if one could be found, there must be many more. This realization transformed astronomy overnight. Suddenly, the hunt for other worlds was no longer speculation, it was science. From that moment, the question shifted, not if planets existed, but how many. And could any of them be like Earth? 51 Pegasi b became the spark that ignited the search for Earth 2.0, a planet where oceans could flow and life might one day be found. In 2009, NASA launched the Kepler Space Telescope, a mission designed to follow in the footsteps of 51 Pegasi b. Instead of watching for wobbles, Kepler stared at 150,000 stars, searching for tiny dips in brightness as planets crossed in front of them. This method, called the transit technique, turned out to be a revolution. Over the next 9 years, Kepler discovered more than 2,600 confirmed exoplanets, from burning lava worlds to super-Earths to planets orbiting in the so-called habitable zone. Each discovery traced its roots back to that first signal in 1995, proving that planets are not rare, they are everywhere. Not every planet can host life. For that, a world must sit in just the right place, not too close to its star and not too far away. Astronomers call this the habitable zone, the region where temperatures allow liquid water to exist. It is sometimes called the Goldilocks zone, not too hot, not too cold, but just right. 51 Pegasi b was far too close to its star, a blazing inferno with no chance for life. But its discovery proved that stars could host planets of all kinds, and hidden within those systems, some might just fall in the sweet spot, worlds that could look a little more like our own. In the years after Kepler, astronomers began to find something extraordinary. Worlds that weren't just gas giants or burning hot Jupiters, but rocky planets, roughly the size of Earth, orbiting in their star's habitable zone. Kepler-186f was one of the first, a planet just 10% larger than Earth, receiving a gentle amount of sunlight from a dim red star. Then came Kepler-452b, nicknamed Earth's cousin, orbiting a star much like our own, though 1,400 light-years away. And even closer to home, in 2016, scientists discovered Proxima Centauri b, a rocky world circling the star nearest to us. Each of these planets whispered the same possibility that Earth might not be unique. Finding an Earth-like planet is only the first step. The next challenge is to search for life itself. Astronomers look for what they call biosignatures, gases in a planet's atmosphere that could only be produced by living things. Oxygen, for example, is highly reactive. On Earth, it is constantly replenished by photosynthesis. Methane can also hint at biological activity, especially if found alongside oxygen. Future telescopes, like the James Webb Telescope in the planned LUVOR and HABEX missions, will be able to analyze the atmospheres of distant exoplanets. One day, we may look at a spectrum of light and see the fingerprints of alien biology staring back at us. From a blazing gas giant called 51 Pegasi b to rocky worlds like Kepler-186f and Proxima b, the past 3 decades have transformed our place in the universe. What began in 1995 as a single strange discovery has grown into a catalog of thousands of worlds, each more diverse and surprising than the last. Some are oceans of fire, some are frozen giants, and some, perhaps, are quiet blue dots where life could be waiting. The search for Earth 2.0 is not just about astronomy. It is about us, about understanding whether life is rare or inevitable. And maybe one day we will look up at the night sky, point to a star, and know with certainty we are not alone.